worked example is actually really similar to worked example 6 in as much as it involves using a differential equation. We've just got different variables here. You'll notice this time we've been given acceleration, although they haven't written acceleration as a equals, they've written acceleration as its rate of change relationship, dv dt, the rate of change of velocity with respect to time. But aside from that, we've got acceleration in terms of velocity instead of acceleration in terms of time, and we want to find velocity in terms of time. So it's almost the exact same set of working as we did in that last example. We're just working with different variables and a different type of equation. So if we rewrite our question, okay, we can't take the dt across the other side because then we would be integrating with respect to time instead of with respect to velocity. So we're going to flip both sides of the function there. So we would get dt dv equals 1 over v plus 1. Alright, so slightly different type of equation to integrate there. But our next step remains the same. We're going to take the dv across the other side, which means that we will be integrating with respect to velocity. As a general rule, whatever variable is there is a variable that also has to be a part of the function. If those two things don't match, then you can't integrate because you're not integrating with respect to the right variable. Alright, thinking back to Maths B, term 2, okay, the integral of 1 over x is log e to the x. In this case we have 1 over something, or the other way of looking at it is that is v plus 1 to the power of negative 1. Any way you want to think about it, when we integrate that, it's going to go back into a natural log function. And it has our plus c. Okay, we were given the information in the question. I didn't write it down at the top and I should have, but when the velocity equals 0, the time equals 0. So we can again use that same kind of logic to go when v equals 0, t equals 0, and therefore c will also equal 0 if that's our case there. Because the log, yeah, so that will work there as well. Alright, so the log of 1 is 0 if you do it on your calculator. That's why that still works there if you need to check that out. Okay, so we're at the stage now where we have t equals log e of v plus 1. Okay, we don't have a plus c anymore because we know it equals 0, but we need this written as velocity in terms of time. So we need this written as v equals. Now this is actually easier to rearrange than the other one. In the other one we had to use completing the square or factorise it somehow, but we've only got one v. Okay, so we don't have to do anything to it. We don't have to factorise, we just have to rearrange it. So we're going to, instead of writing that in log format, we're going to write it in index format, which means that's our base, that's our power, that's our answer. So v plus 1 equals e to the power of t. Okay, and then we would take our 1 across the other side, and we now have velocity in terms of time. Easy.